Okay, Year 7, welcome to Polyhedra, nets, and Euler's Rule. These are the three things we're going to be learning about. So you need to have a heading in your theory or your grid book. In red, underlined, Polyhedra, nets, and Euler's Rule. Okay, and you need to be writing this definition. A polyhedron is a three-dimensional shape in which each flat surface is a polygon. Hence the name, guys, polyhedron. It sounds like polygon. Polyhedron is just a three-dimensional shape in which each flat surface is a polygon. So we've looked at polygons. We've looked at polygons here, guys. And polygons are flat. We've been looking at flat shapes. Now we're looking at polyhedron, and they're 3D or three-dimensional. So in a polyhedron, the flat surfaces which make up the polyhedron are called faces. You can see here, guys, have a look at this diagram here. This lists everything for you. I would like you, underneath this definition, once you finish writing that all out, to draw this shape. So, flat surfaces which make up the polyhedron are called faces. As you can see here, the face is labelled. Okay, on this diagram here, faces. Okay, the lines where two faces of a polyhedron meet are called the edges. So, let's get rid of our lovely big circle Mr. Corsi drew around here, and let's actually have a look at this shape in this diagram. So it says the faces are the flat surfaces. This is a face here. Okay, that's a face there. You've got a face on top. You've got a face on the side. Okay, the part where the faces meet, okay, the part where the faces meet are called the edges. This is an edge here, guys. Down there. That's an edge there. Okay, that's an edge there. These are all the edges. Okay, the points where three or more edges meet are called vertices. So here's a point. Here's a vertice, sorry. Here's a vertice. Okay, you can't see it from this side, but here's a vertice here, and here's a vertice here. Okay, this is not a vertice. Why not? It's only two. So at this point there's only two vertices here, 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 and here. That's where three or more edges meet. They're called the vertices. So writing out this definition here, guys, all of the words there, plus drawing this diagram. Okay, that's what you need to be having under a heading Polyhedra, nets, and Euler's Rule. So that's what a polyhedra is, or a polyhedron. Okay, we're learning about multiple polyhedra, which are called polyhedron as a group. Writing out the definition, drawing the picture. Okay, so moving on to nets of polyhedra. Again, you need to have a subheading. Also write it in red, nets of polyhedra. And you need to be writing this definition here, guys. So it says a two-dimensional plan that can be folded to construct a three-dimensional polyhedron is called a net. Okay? So if you look here at example, this is a two-dimensional plan right here. Okay? This is a net of the square pyramid that we have here. So this square pyramid, oops, that was the worst arrow I've ever drawn. So this net, this two-dimensional shape here is a net. Okay, it's a two-dimensional plan of this 3D polyhedron. Okay, this is a square pyramid. We've already had a look at pyramids. It's called a polyhedron. This is a net of it. So as I've already written down here, guys, you need to be drawing these pictures. Drawing this picture here, also drawing its comparative, and actually having a heading net of a square-based pyramid. Actually be writing that, net of a square-based pyramid. So it says this is a net of a square-based pyramid. If you fold the triangles up, so imagine we're folding this triangle up, this triangle up, this triangle up, and this triangle up, and stick them together, it'll actually form this object over here, which is our square-based pyramid. So what we're doing when we're doing nets is we're essentially folding out a three-dimensional object to be 2D. That's what we're doing. This is an example of what the 2D object of what the 3D object of a square pyramid would look in a two-dimensional plan. So I'll rub that out, guys. I'll rub out all the information that I put over here in case you want to go and actually have a clear view of the square pyramid here, just to make it a little bit easier for you. So I'll rub out all these lines, okay? And what you need to be doing is, under this definition that you've written, drawing this drawing this square-based pyramid with both this 3D version, so what the square pyramid looks like as a three-dimensional object, and our net, or our two-dimensional plan. Okay, labeling it square-based pyramid. If you'd like, you can write this text here if it'll help remember. All I'm asking for, really, at a bare essence, is the three-dimensional object, the 2D plan, and it labelled net of a square pyramid. Finally, guys, the last thing that you need to understand here is Euler's Rule. Now, this seems really complicated. It's actually super simple. You need to be writing a heading, Euler's Rule, and you need to be writing the definition that's here on this page. It says Euler's Rule for polyhedra can be stated as, for any polyhedron, f plus v minus e equals 2. So that's that statement, f plus v minus e equals 2. Okay. This is what we call an equation. Okay. You only have to remember the equation and then substitute the relevant values. So it's saying f is the number of faces, v is the number of vertices, and e is the number of edges. Okay, so how many vertices do we have here, or how many faces, do we have here in this square-based pyramid? I'm going to do an example of applying Euler's Rule so you guys understand it. So we count our faces. We have 1, 2, 3, 4, 5. So first let's substitute. We'll write it down. F plus v minus e. Just of course you rub that out. Minus e equals 2. So if the polyhedra is correct, it's meaning that the number of faces plus the number of vertices minusing the edges should equal 2. If it doesn't equal 2, then Euler's Rule does not apply. So that's the formula we're working with. Now let's apply it to our shape here. So we've counted the number of faces and we've come up with 5. Plus, how many vertices do we have here, guys? Should be able to count these. We have 1, okay, 3 points, more than 3 points meeting. 2, 3, 4, 5. There are a number of vertices because you have this face, and the bottom face meeting. That's 3 polyhedron. 2 triangles and a square at the bottom. That's 3 points meeting, so that's a vertice. So 5 plus 5. Subtract, how many edges do we have? Okay, now it's a matter of counting the number of edges. So let's go in here and count the number of edges. If you want, guys, drawing this picture and ruling over with another colour can be a good way to count. We've got 1, 2, 3, 4, 5, 6, 7, 8. See what I've done there? I've just ruled my pen over the number of edges. So, subtract 8 equals, now, remember our order of operations. Brackets, operation, division, multiplication, addition, subtraction. That's our order of operations. There's no brackets. Don't have to care about operations. There's no division. There's no multiplication. The next is addition and subtraction. So we have to add these two values first. 5 plus 5 is 10. Subtracted by 8. Okay, 10 minus 8 is 2. So Euler's Rule has been proved with this. This is what you guys need to do. Substitute. So take Euler's Rule, this equation here, okay, and apply it to whatever situation. You'll either be asked to prove and given a picture or being told the number of faces. And that's it, guys. That's all you have to do. Please let me know. I don't know what you have done so far. If you don't know what your order of operations is, so if you don't know what BODMAS is, make sure you come and see me and I'll explain it to you guys. Getting on with the exercises now that are also posted on Edmodo.